Allotropes of carbon. The element carbon occurs in different forms in nature with widely varying physical properties. Both diamond and graphite are formed by carbon atoms. The difference lies in the manner in which the carbon atoms are bonded to one another. In diamond, each carbon atom is bonded to 4 other carbon atoms, forming a rigid three-dimensional structure. In graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. One of these bonds is a double bond. Graphite structure is formed by the hexagonal arrays being placed in layers one above the other. These two different structures result in diamond and graphite, having very different physical properties even though their chemical properties are the same. Diamond is the hardest substance known, while graphite is smooth and slippery. Graphite is also a very good conductor of electricity. Diamonds can be synthesized by subjecting pure carbon to very high pressure and temperature. These synthetic diamonds are small but are otherwise indistinguishable from natural diamonds. Fullerenes form another class of carbon allotropes. The first one to be identified was C60, which has carbon atoms arranged in a shape of a football. This looked like a geodesic dome designed by the US architect Buckminster Fuller. The molecule was named fullerene. Versatile nature of carbon. The formation of covalent bonds by the sharing of electrons in various elements and compounds. The nature of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon are: first, carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in rings. Carbon atoms may be linked by single, double, or triple bonds. Compounds of carbon, which are linked by only single bonds between the carbon atoms, are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. No other element exhibits the property of catenation to the extent seen in carbon atoms. Silicon forms compounds with hydrogen which have chains of up to 7 or 8 atoms, but these compounds are very reactive. The carbon-carbon bond is very strong and hence stable. This gives us the large number of compounds with many carbon atoms linked to each other. Second, since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with specific properties which depend on the elements other than carbon present in the molecule. Again, the bonds that carbon forms with most other elements are very strong, making these compounds exceptionally stable. One reason for the formation of strong bonds by carbon is its small size. This enables the nucleus to hold on to the shared pairs of electrons strongly. The bonds formed by elements having larger atoms are much weaker.